Good morning, and welcome to today's webinar on the topic of functional maize and wheat alternatives. I'd like to thank you all very much for taking the time out of your day to join us on what's a very contemporary issue, and one which I'm sure is quite pressing for a lot of you viewing at the moment. So I hope you'll enjoy this, as well as taking away some practical solutions as well. My name is Robert Lambert, and I head up marketing and communications here at Ulrick & Short, and I'll be your host for the duration of the webinar. With me on this webinar are two of my colleagues. Firstly, we have John Ellis, who's one of our business development managers.
Hi there.
And we also have Emma Walker from our technical field support team.
Hiya.
So over the next 30 minutes, we're going to be looking at three key areas. Firstly, why it is a good idea to be looking for alternatives now, and what sectors will be acutely impacted by this situation. Secondly, John will take you through the types of maize and wheat starch available and their specific properties, as well as the properties of some potential crop alternatives. And finally, Emma will talk you through some worked examples, showing you how these can practically work in a few different sectors and applications. Before we start though, just a bit of housekeeping. So throughout the webinar, we'll be putting up a poll, as well as some scannable QR codes for some useful downloadable resources for you. So you may wish to have your phones at the ready so you can scan these as we go through. Please feel free to put any questions in the Q&A section below. We won't have time to answer these live on the webinar, but if you do have any questions, we'll pick up these immediately after the webinar today. Alternatively, at the end of the webinar, there will be John and Emma's contact information if you have any specific queries or questions on what you've seen, or if you're an existing customer of ours or you're already in touch with us, please feel free to get in touch with your account manager. And finally, you'll be receiving a recording of this webinar following this, as well as all the downloadable resources. So please don't feel like you have to scribble notes down or screenshot anything, because it will be available all the way afterwards. So to start with, what I want to do is actually throw the question back to you. So what I'm going to do is put out a poll. This is a completely anonymous poll, so nobody will see your specific results. And this poll is asking you, what is your current experience with ingredients regarding maize and wheat? Are you currently experiencing significant supply chain disruption in this area? Are you aware of it and experiencing it ever so slightly? Or are you currently unaffected by this? And I think this will just give us a nice gauge as to where everybody's at. That's great. Thank you all for voting, by the way. This is fantastic. Okay, I'll just give this 2 more seconds. Brilliant. Thank you all very much. So I'll just share these results with you guys. So obviously we have a bit of a spread here, but I think generally speaking, we can see more often than not, the industry as a whole is feeling this problem, this challenge quite acutely. So let's delve into this some more. So the increases in price of maize and wheat can really be boiled down to simple economics, insofar that there's been an increase in demand since COVID has lifted and the supply has declined. Now, there are two main reasons for the shortage. The first reason is that the harvest in both 2020 and in 2021 was poor. So the situation going into 2022 was already precarious and prices were already at a historic high. And you can see from this graph here, if you look at Q3 of 2022 and Q3 of 2020 and Q3 of 2021, there were price hikes in both. The second factor is obviously the elephant in the room, which is the Ukraine situation. So Ukraine is responsible for 16% of global maize production and 9% of global wheat production, with Russia also being a very major producer in both of these as well. which of course, as of February, it became pretty much commercially unavailable. These products became commercially unavailable from these territories. What makes the Ukraine situation even more pertinent is it means the harvests in 2022 will be very, very low, as very little has been planted. Of course, we'll only know this situation fully as we go throughout the year. But what this means is that this shortage of maize and wheat is at least a medium-term situation. So it will go through into 23, 24, and potentially beyond, even if theoretically everything ended now and things resumed normality. Additionally, in 2022, inflation is a fact of life. In the UK here, it's just hit 9.1% this week. So rising energy costs and fuel costs are making both production and transportation exceptionally expensive when it is possible to produce maize and wheat, although this is by no means exclusive to these two raw materials. And as you can see here, the result is pretty staggering. So this graph shows raw material grain price of maize and wheat. So as you can see, in the 24-month period between April 2020 and April 2022, maize price increased nearly 240%, from $147 per ton to $348 per ton. With wheat, this was even more severe, with an increase of over 300%, from $221 per ton to $672 per ton in April 2022. So how does this relate to the food industry? So maize and wheat starches are the base crop. Maize and wheat are the base crop for a variety of functional ingredients, highly functional ingredients, such as starches, flours, or proteins. And these provide a multitude of functionalities in a range of sectors and applications, some of which John and Emma will come on to very shortly. So this graph here shows just how widely used maize and wheat starches alone are used in a variety of applications. So this graph shows the last decade of retail food product launches in the UK, and it's broken down by sector. And it shows in each sector the proportion of product launches which have just a maize starch or a wheat starch declaration. So as you can see, it's very, very widely used in a range of sectors. Bakery looks like it will be the most acutely impacted, with nearly 40% of all product launches having either a maize or a wheat starch declaration. But it covers anything from ready meals, soups and sauces, desserts, even confectionery as well, all of which are likely to be significantly impacted by this. So how is it possible to overcome such a significant challenge? So unfortunately, there's no one-size-fits-all solution to this or one magic ingredient to this, as these ingredients are so widely used and are so multifunctional. So firstly, what you need to do is fully understand specifically what your ingredient is doing in application. So we work with you really closely to design and develop new formulations using genuinely viable alternatives. And all of the solutions that we have, and you're about to see, are clean label. And by clean label, I mean they've undergone zero chemical processing whatsoever. And instead, we extract the natural functionality of the base crop using protected physical production methods. And as a result, all of our ingredients carry a very clean and consumer-friendly back-of pack declaration. And everything we do really revolves around technical support. So our commercial and support teams can help you at any stage of your development process, whether this is at the kitchen concept stage or whether it's all the way through to factory trials and production stage. And that's really just to help you get the best out of the ingredients. So to go through this in some more detail, I'll now pass you over to John, who will talk you through some of the functional properties of the different types of maize and wheat, as well as some potential alternatives.
Thanks, Rob. So let's have a look at some of the raw materials and their properties in more detail. Let's start with native maize starches. So native maize starch comes in a few different forms, and the main ones we're interested in the food industry are waxy maize and dent maize. Both of them look the same. You'll recognise them from eating corn on the cob. However, they have very different functionalities. Let's start with waxy maize. So here we have a starch gel, which is made up of 5% cook-up starch and 95% water, which is then cooked in a pan in the kitchen, transferred to a beaker and left to cool. It's a great way to assess a starch's physical properties. So here, looking at waxy maize, we can see some of the properties. Under the microscope, you would see that the granules of starch are quite angular. When we think about this in terms of its texture in the mouth as being quite angular and almost like gravel. So imagine sticking your hand in a bucket of gravel is some of the textures that you might experience. Physically, you can see there, the way that we describe this is that it is long and snotty. In terms of clarity, you can see it's nice and clear. And typically, this would get used all across the food industry into many applications, particularly we see it in sauces and ready meals. And so here we're looking at the native dent maize. And again, under the microscope, you would see that it is an angular granule. And so again, we're thinking about sticking a hand in a bucket of gravel for its textural properties. Now looking at the starch gel, you can see it looks very different. We describe this as being short and brittle. And if we look at the cloudiness of it, or the clarity of it, you can see it is very cloudy. Again, this is used in the food industry. It's less common than the waxy maize, but gets used widely into things like gluten-free breads and confectionery, where it's used for moulds for jelly babies and such like. So waxy maize and dent maize are really interesting to look at, as they give the extremities of texture that you'd ordinarily find in the food industry, and almost everything fits in between these two. Let's have a look at the properties of wheat. I'm sure you're all familiar with eating wheat in breads, cakes and pastries. So under the microscope, you'll see that the granularity is that of round and flat granules. There are two distinct sizes, and we think of this as being like pebbles on a beach. So imagine walking down a beach and there's pebbles rolling around underneath your feet. That's the sort of meshing that you get. So they don't roll perfectly, but they do slip and slide a bit. Now, in terms of the starch gel, you can see there the texture is again short and brittle. It's actually a slightly weaker gel than the native dent maize. Again, it's cloudy. Largely, we'll see a lot of wheat starch being used in bakery applications. So that's the properties of the materials which are going into short supply. So let's now have a look at some alternatives. The first one we're going to look at is rice. Now you'll be familiar with rice as an accompaniment to curry or chili. Under the microscope, you'll see small cubes, and it is distinctly much smaller in granule size than other starches. And because it's so small, it's still quite angular and actually sort of square cuboid shape. But what you feel is it's a bit like sand. And so you actually get some smoothness of it because of its small size. Now, as a starch gel, you can see that it's kind of between the two, or between the waxy and the dent on our sort of sliding scale. And equally, the clarity is between the two. Typically, we would see rice starches being used into applications such as fruit preps, dairy applications, and some sauces. So the next one we're going to look at is pea. And when we talk about pea products, it's yellow split peas we're talking about rather than green garden peas. This is the sort of thing you'd have in a soup or stew or a dal. And under the microscope, you would see an elongated or baked bean type shape of granule. So these will roll over each other and give some smoothness, but not perfectly. And as you can see here, the starch gel produced is very, very short and very brittle. It is beyond our limit of our waxy to dent scale. It is beyond the dent maize. And also, if you look at the clarity of it, you can see it is very, very cloudy. Again, beyond that of the dent maize. The classic application for pea starch is into injected and tumbled meats, which are going to be sliced. Here, that very firm and short texture helps to give something solid for the knife to slice against, to give you a good, clean slice without producing lots of fines. So the next crop is actually our biggest selling crop, yet it's something that you may have never eaten in its natural form. Tapioca is a staple crop of South America and grown in regions around the equator. There it is eaten like we eat potatoes, and they boil it, they mash it, chip it and fry it, as well as grinding it into flours for breads and for cakes. Underneath the microscope, you would see a very round spherical granule. So we're thinking here about putting a hand in a bucket of ball bearings and that very smooth, very slidey, very slippy texture that you would get. And in the starch gel, you can see there's a very long and stringy texture to it. It's also almost as clear as the waxy maize starch. Now, tapioca is widely used in the food industry, and we particularly see it going into fat replacement solutions and sauces. So our final crop to talk about is potato, which should be familiar to everybody. We all like a chippy tea. But under the microscope, you'd see the granularity is again an elongated or baked bean shape. So again, semi-smooth, will roll over each other, but not perfectly, not quite like the tapioca. And the texture that you get in the starch gel is quite long and flowing, and it's almost clear. Potato starch quite often gets used into meat applications, particularly as its low gel point really helps. So that's all the base crops that we're going to look at. And you've seen how we can match the properties of some of the alternatives to the maize and wheat starch. But these are all native starches and are not the products that we work with, only the raw materials. So what do we do in our processing? Well, our starches are processed in a clean way, which means using natural processing methods and avoiding the use of chemicals. And why do we do this? Well, it gives us the opportunity to manipulate the properties of the starch in your application, whether that is the textural properties to remove some of the long, stringy or snotty textures, or to improve the functional properties such as acid or shear resistance, or to improve freeze-thaw stability. So let's pass over to Emma to have a look at some of these alternatives in application.
Thanks, John. So in the upcoming section, I'll be speaking through 3 different application areas where maize starch is predominantly used. And I'll speak through the solutions that we've developed in order to replace these successfully whilst maintaining overall product quality. So firstly, we'll look at the replacement of a pre-gel maize starch in cake batter. So theoretically, pre-gel starch is binding water within the mixture and therefore increasing the overall batter viscosity. This will thicken the batter viscosity to a level where it's ideal for depositing within a factory process. It's also the increase in batter viscosity, which allows for the water to become trapped and kept in place over life. This results in a product with retained moisture and improved softness over the duration of its shelf life. Additionally, by increasing the batter viscosity by a certain level, you're able to improve slippage of inclusions such as chocolate chips or raisins, for example. So during the development of an alternative, it was critical to ensure that batter viscosity, moisture retention, and product quality all remained similar to the maize counterpart. As a result, we now have a solution under the name of Fazenda Nutrigel, declared as a pre-gel rice flour. For optimum results, we recommend a 2% dosage level, and this is usually taken away from the greatest ingredient in the recipe. So in this case, in a cake, it would be flour, for example. So as previously mentioned, it's the moisture retention and the softness, which is a big selling point for the pre-gel maize. However, in this graph, you're able to see that the addition of Fazenda Nutrigel compared against our Synergy XS, so maize pre-gel, is very, very close in softness. It requires similar levels of force from the use of a texture analyzer machine. Although the Fazenda Nutrigel is slightly less soft, there is less of a difference detected between day 1 and day 7 compared against day 1 and day 7 for maize. In this next graph, we've measured batter viscosity using a consistometer. So this looks at the flow of the batter over a period of 60 seconds under its own weight. Again, you can see that the results are very, very similar to the maize counterpart, and no significant differences are noted between the batter flow, suggesting a simple swap should result in no difference in both factory processing or finished product quality. So the next application area I'm going to speak you through is tumbled meat using our Easy Moist range. So typically, some of our Easy Moist ranges, including Easy Moist 12 and Easy Moist 6, are maize-based and showcase a typical yield between 86 and 96%. But we now have tapioca and potato-based solutions, which can help improve yields, as well as improving overall succulence. Easy Moist 8, a tapioca starch, is one of our solutions available for the replacement of maize in this particular application area. It presents good levels of moisture binding, resulting in improved succulence, with a typical yield of 87%, as well as offering an additional benefit of a lower gelling temperature of approximately 70 degrees Celsius, compared against Easy Moist 12 at 80 degrees. This offers you and your customers the opportunity to sous vide meats at lower temperatures. Additionally, our tapioca starches have gone through an additional processing method, which means that the starch is able to withstand low pH if you're to further marinade, for example. The second solution we have available is Easy Moist 17. So this is a potato starch. It presents a smooth mouthfeel and again, a lower gelling temperature of around 72 degrees. So the two products we've spoken about are both tapioca and potato. And as John has touched on, they're round spherical granules, which also allows for a clean flavor profile. The final category I'm going to speak you through is sauces. So we now have a range of starch-based solutions centered on tapioca and potato, both hot and cold sauces. Typically, maize starch is used for its short texture and advantage in preventing boil out in pies and slices, for example. So in R&D, we've been working really hard and we can now offer a potato-based solution known as Synergy L526P for hot sauces and L626PGA for cold sauces. These will provide a short texture whilst also providing a smooth mouthfeel. It's also important to note that the L626PGA is a slightly larger granule size and therefore has a slower hydration rate. Additionally, tapioca-based starches, including Synergy L526 for hot sauces and L626 for cold sauces, will provide a smooth and creamy mouthfeel, a glossy appearance, and a clean flavor profile. since the granule shape is spherical and therefore more mouth coating. Due to the clean process they've gone through, they're also able to withstand high shear processing, low pH conditions down to a pH of 3.5, and high temperature processing. Also, we would use most of these products at approximately 2 to 3%, but this will vary depending on the type of texture that you're looking to achieve. Thanks for listening. If you need any more information, please feel free to contact us. I'll now pass back to Rob to finish up.
Thank you very much for that, Emma and John. Some really, really interesting stuff there. So this concludes this short webinar. We hope it's been informative and given you some interesting ideas and solutions. If you do have any questions on any of the concepts or ingredients you've seen today, please feel free to get in touch. There's John and Emma's contact details here, or there's a more generic email address here. But as I say, if you're already in touch with us, please feel free to get in touch with your account manager. They'll be your best port of call. Additionally, you can put some questions in the Q&A function here. We'll keep the webinar open for a few minutes if anybody wants to do that. So the last thing to say is thank you all very much for your time, and we hope to see you at our next webinar, which will focus on plant-based dairy concepts and the formulation challenges around that. We hope to see you soon. Thank you. Goodbye.